Hey everybody, welcome back from spring break. And what we're going to do is spend a couple days just kind of going over what we did before we left for spring break. So what I did was I made this chart worksheet for you with kind of highlights different important things in purple and green. So just kind of starting off that trigonometric functions for acute angles. Trigonometry is the relationships among the angles and sides of a right triangle. So if you look at this chart right here, remember that the opposite and adjacent sides depends on the angle you're looking at. So for instance, this chart is looking right here at angle A. And as you can see, that angle A is the focus of where they put opposite, hypotenuse, and numerator in the denominator. All right. So likewise, if they were looking at angle B, then the hypotenuse, which is right here, would stay the same because it's always across from the right angle. But if we were looking at angle B, then our opposite and adjacent sides would change. So that's very important before you start to look at what angle they're looking at, because that'll kind of determine what your numerator and denominator are. So if we look at example 1, in a right triangle, angle B is acute, and cosine of B equals 3 over 7. Find the value of tangent B. So what you got to do is, what they're doing here is they're giving you that the cosine of angle B, which is this guy right here, is 3 over 7. So that lets me know I'm going to go up to this handy dandy chart I have, and the cosine is adjacent over hypotenuse. So what that means is that 3 is my adjacent side, and hypotenuse, of course, is 7. All right, so what they're looking for is the tangent of B. So they're looking for the opposite over the adjacent side, but we don't have the opposite side right here. So what they do is they walk you through the step-by-step process of using the Pythagorean Theorem, and they found that B was the square root of 40, or written as 2 times the square root of 10. Okay, it doesn't matter. I'm okay with however you want to do those two. So now they find the tangent of B, and they just plug in what they have. So the opposite side is now 2 root 10 or square root of 40. So what they did was they just put that in the numerator, and the adjacent side is the denominator of 3. All right, so let's put this into practice. All right, so for number 1, we're looking here at the angle O right there. All right, so first things first, I'm going to label what I have, and I know that this is my adjacent side, and I know this is the hypotenuse because it's across from the right angle, and that means 5 is my opposite side. Okay, so I'm going to need to do the Pythagorean Theorem in order to figure out what my missing side is, which is that adjacent side. So we'll go ahead and plug in our numbers as a squared plus, get rid of that, plus 5 squared equals 13 squared. And you use your calculator and you find out that a squared plus 25 equals 169. Okay, so at this point you do your basic algebra that you've done before, and you end up with a squared equals 144. All right, and in order to figure out what a is, we take the square root of both sides. So we're going to take the square root of both sides, and the square root of a squared is just going to be a, and the square root of 144 is 12. So that means my adjacent side is 12. So I'm going to come over here and put a 12 right there as a reminder. Okay, so now when we're going to get the 6 functions, we're just going to look at each one of these functions in our chart and just put them in the numerator or denominator wherever they belong. So let's go ahead and start with sine. So the sine is going to be opposite over hypotenuse, and that's 5 over 13. Again, I'm just pulling from this little diagram that we have right here. Cosine is adjacent over hypotenuse. So I've got 12 over 13. Tangent is opposite over adjacent. So I've got 5 over 12. Let's see here. Cosecant, hypotenuse over opposite. So I've got 13 over 5. Secant is hypotenuse over adjacent. Whoops. Hypotenuse over adjacent, which is 13 over 12. And cotangent, which is adjacent over opposite, which is 5, let's see here, 12 over 5. And those are your 6 trigonometric functions for angle theta. Okay? All right, now your assignment is to go ahead and take care of number 2, and I'll make that more clear at the end of this video. Let's go ahead and look at example number 3 here, right here. And what's going to end up happening is you guys are going to end up doing the even 2 and 4. Okay, so in a right triangle, let's start with number 3 here. Let's switch it up. Here's number 3. I'm going to separate that right there. Number 3 says, in a right triangle, angle A and angle B are acute if the tangent of angle A equals 7 over 12. What is cosine of angle A? I like to draw a diagram when I do these, so I'm going to draw a triangle. All right, and I know I have a right triangle, so that means this is the hypotenuse. All right, so what I'm going to do is put angle A over here. So that means the side adjacent to A is going to be the adjacent side. And the beautiful thing about right triangles is if I would have made this angle A, this would have been my adjacent side. But using that Pythagorean theorem glues everything together. So that means this is going to be my op. All right. Depending on how you draw your diagram will just determine where you'll label everything. Okay, so what I'm going to do now is label what I have. So the tangent of A, so that means tangent is opposite over adjacent. So my opposite is going to equal 7. It says right here, 7. And my adjacent is going to equal 12, which is just going based off of the chart. The only thing I don't have is the hypotenuse, okay? So we're going to use the Pythagorean theorem again to figure out what the hypotenuse is. All right, so we're going to say 7 squared plus 12 squared equals c squared. Remember, c is always the hypotenuse leg. All right, so we'll go ahead and square these. And we end up with 193 equals c squared. Okay, now remember, to get rid of that exponent, we're going to have to take the square root of both sides. So we're going to take the square root of both sides, and I end up with c equals the square root of 193. So that is my hypotenuse now, right there. Oops. I don't know why that did that. There we go. So that means my hypotenuse is the square root of 193. And we'll just leave it like that because we're not going to try and break down the square root of 193. We know it's not a perfect square, and we're just using it to find a hypotenuse side. So we don't have to go too far into detail. All right, so let's go ahead and see what they're asking. They're asking for the cosine. So cosine tells me that adjacent side over hypotenuse side. So I have my adjacent side. Let me go ahead and write here cosine equals adjacent side over hypotenuse. So I have an adjacent of 12. And I have a hypotenuse of square root of 193. Okay? And in a perfect world, we would just stop right there, but we don't want to leave a square root in the denominator. So we're going to multiply both sides by that denominator, the top and bottom, to get rid of that square root. And I end up with 12 times the square root of 193. And any square root times itself is just the number under the square root. So we're just lifting the square root off, and we get 193 as our final answer. Okay? All right. Your assignment then for the Tuesday, April 14th is going to be number 2 and number 4. And I will post that on your Google Classroom. Email me or message me if you guys have any questions.